How can a hand-sized reef shrimp punch so fast it makes water boil? And why does it see colors and secret light we cannot? Meet the Peacock Mantis shrimp, a rainbow hammer with superhero eyes. In slow motion, its club blurs forward. A white bubble blooms at the hit, then it pops. That is not heat. That is the ocean flashing to vapor for a blink. It gets wilder. This same animal sees from ultraviolet to deep red. It also reads the twist and angle of light that most eyes ignore. It does all of this from a burrow in a coral reef. It is small, it is patient. Then it moves like a sprung trap. The name is Odontodactylus ciliaris. People call it the Peacock Mantis shrimp. It is not a true shrimp. It is a stomatopod, which is a different group of crustaceans with raptorial hunting arms. Think of a lobster relative that picked a fence over armor. You find it across the Indo-Pacific, East Africa to Japan, the Philippines and Indonesia, the Great Barrier Reef and Northern Australia. It lives where coral makes rubble fields and holes. It likes a solid roof and a front door with a view. An adult is about the length of your hand. 10 to 18 centimeters is typical. It lives alone in a burrow. The entrance is neat and guarded. A gentle current brings the news of the reef, a snail, a crab, a clam that wandered too far. This is a smasher-type mantis shrimp. That means it hunts hard-shelled prey. It does not stab soft fish. It breaks armor with repeated hammer blows. The first hit stuns, the next hits crack. The shell fails. Dinner is served. They do not brawl all day. They have a signal to avoid it. When a neighbor creeps too close, the resident lifts and flares the forelimbs. That is called a merrill spread. It is a bright show that says, "I am ready." Often that is enough. The weapon is a spring-loaded hammer. The striking arm is called a raptorial limb. Inside is a saddle-shaped spring in the shell. The muscle pulls it slowly and stores energy, like bending a bow with a winch. A tiny latch holds the system cocked. When released, the club, which is called the dactyl, whips forward. Muscle powers the loading. The spring powers the hit. Slow in, explosive out. That is the trick. How fast is it? High-speed video captured the numbers. The club can reach about 23 meters per second at peak. The acceleration can exceed 10,000 times gravity. That is one of the fastest strikes in the animal world. Contact is over in 2 or 3 milliseconds. That is 2 or 3 thousandths of a second. Blink and you miss it by a mile. Even a glancing hit can hurt the target. Because the physics after the hit matter just as much as the hit itself. Here is the weird part. The club moves so fast that pressure around it drops. The local pressure falls below the point where water stays liquid. A vapor bubble forms right at the impact site. The water boils without heat. That is called cavitation. Then the bubble collapses. When it pops shut, it sends a second shockwave into the prey, so the target gets hit twice, first by the club, then by the bubble collapse a hair later. That second hit can finish a crack that just started. A quick note here, people sometimes ask if it makes light. Flashing light from collapsing bubbles is called sonoluminescence. That effect is debated around mantis shrimp hits. The big sure thing is the extra shock from the bubble collapse. That one is real and repeatable. You might ask why the club does not shatter. The face of the club is not a simple shell. It is a layered composite. Chitin fibers and mineral are stacked in a twisting herringbone pattern. That pattern spreads force and deflects cracks. When a crack starts, it turns and loses steam in the maze of layers. The energy gets bled off through the stack. That saves the club from fatal breaks. Engineers copied this design to build tougher impact materials. Helmets and armor now borrow from a shrimp. Now the eyes. Each eye sits on a stalk and can move on its own. Across the middle of the eye runs a set of 6 narrow rows. Think of 6 tiny scanners sweeping the scene. They sample color and the way light is lined up. These eyes hold about 16 photoreceptor types. Humans have 3. About 12 of the shrimp receptors are for color. They span from ultraviolet to deep red. The others are tuned to polarization, that is the orientation and twist of light waves. Each eye can roll, scan, and track without the other. Each eye can judge depth by itself. That is because parts of the eye see the same spot from slightly different angles, so one eye gives a kind of 3-point view. Trinocular vision in one package. What is polarized light? Picture light as tiny waves with a direction. Linear polarization is waves lined up in one plane. Circular polarization is waves that twist like a corkscrew as they travel. The shrimp sees both types. Special filters in the eye, in a cell called R8, act like a quarter wave plate. That turns one kind of polarization into another, so the sensors can read it. Rows 5 and 6 in that midband read circular polarization. The reef becomes a secret signal board that most animals cannot see. On real reefs, some patches on stomatopods reflect polarized light. To us, they look normal. To a mantis shrimp, they flash bright signals. It likely helps them talk to each other in a private channel. On a crowded reef, that is a neat trick. Here is a twist about all those receptors. You might think more types mean super fine color matching. Tests say not quite. Their color discrimination is actually fairly coarse. Instead of mixing signals like we do, they may tag colors into set bins. That is fast. Good enough for what they need. Speed over fine detail. See it, label it, decide, then strike. That fits the lifestyle. A mantis shrimp has milliseconds to act. A system that says green prey or red rival or bright polarized patch may be enough. The club is already moving while most brains would still be comparing shades. What does this power do on the reef? You can watch them break snail shells and crab armor. The first hits start hairline cracks. Repeated hits drive damage deeper. The bubble collapse adds a final shock. The shell fails along those lines. Aquarists tell stories too. Thin glass can crack if a mantis shrimp finds a corner and hits just right. That is not common in sturdy tanks, but it happens. In any case, the speed and acceleration are the solid numbers. Forces vary with target and size. The club has inspired labs to print and mold herringbone composites. The goal is to stop cracks, the way the shrimp does. Cameras also borrow from the eyes. Polarization sensors now help scientists map reefs and see hidden patterns in water and on skin. Step back and look at it all. In a few inches of armor and optics, evolution built a spring-loaded hammer that can boil the sea by dropping pressure. It also built eyes that read a hidden layer of light. Mechanics and vision meet in one hunter. It is a reef animal that hits fast and sees faster. It keeps a quiet house. It warns before fights. Then it throws one of the wildest punches in nature. The ocean keeps secrets like this in plain sight. If this left you smiling at how weird the world is, stick around. Faunary is all animals and nature, from deep-sea lanterns to tiny tanks like this. Subscribe and drop a like if you enjoyed it. There are more creatures waiting on the channel. See you next time.